Great. So if you remember last time, what we did was we worked with everything that, a lot of things that weren't scripting. So we made some materials, we built a level, we built these prefabs, we brought in the FPS controller, we set up a lot of really cool things that didn't have to do any scripting. Now what we're going to do is we're going to kind of build on top of that and actually build something that uses a bit more actual C# code. So the first thing we're going to want to do, though, is I'm going to go ahead and walk you through how to make a menu scene. So what we'll do is open up your project. If you go to Assets and then a Scenes folder, I recommend that you actually have a scene folder, although you can make any object or any different asset in any folder. This is just for organizational purposes because I don't want to have to dig through 20 folders to figure out where the scene is. So I'm going to go to Scenes, and then I'm going to right-click, go to Create, and Scene. You can also click on the Create button that is just underneath the Project tab. So there's multiple different ways to make this, but I always just right-click because I find it faster. So we'll click Create, and then I'm going to name this Menu. And that's going to build our actual menu scene itself. From here, then, I can switch between any of the different scenes that I currently have by double-clicking on it, and that'll just load up the other scene. And you'll notice all new scenes have both a main camera and a directional light. So something to note is you can name this whatever you want, but it's really important to take note of what the actual name of your scenes are. And you can think of scenes as levels. So this would be like your menu level. Sample scene in this case is going to be level 1. What's really important, though, is making sure that you take note of what they're called, because if you don't, it's really hard to work with any of these. So once we have our menu scene, we're going to go down to our hierarchy down here, and we're going to create some user interface elements. So in hierarchy, we'll right-click, choose UI, and then select Canvas. What user face elements are is if you've ever played a first-person shooter, I'm certain most of you have seen that there's like a little aiming reticle at the center of your screen. What that's doing is just taking a canvas like this, and it's just overlaying images and stuff in front of you. So if we have our canvas selected and press F, we'll see this big rectangle. I'm going to rotate so it's the proper orientation. We're going to see this big rectangle here. And what that is that's just basically the space that the canvas actually has. In our inspector view on the right side, we're going to see a couple of different options related to the canvas itself. For the most part, you won't have to worry about any of this stuff except for this screen space overlay that's part of the render mode. So if you go to render mode and it's currently set to screen space overlay, what that's saying, it's going to take this canvas and whatever the active camera is, it's just going to plop that on top. This is how most things like aiming reticles, health bars, any of those things are done. We can also choose world space if we like. If we choose world space, what will happen is you can think of it as we're going to drop like a whiteboard somewhere and we can put images on that whiteboard. Cool. So then if we select our canvas and then right-click anywhere in the hierarchy area, choose UI and button. I'm going to zoom in on this real quick. Give us just a moment. I'm going to run through this real quick and then come around. In this case, then, we'll create a button here. And so you'll see that the button is on this canvas itself. And then what we can do is move this button around on this canvas. If it goes outside of the rectangular bounds, then you will not see it when you actually play the game. So I'm going to go ahead and just create 2 buttons, because we're going to be using these in just a moment. If you create a UI element without creating a canvas first, Unity will automatically create a canvas for you. The other thing, too, is you are able to move the buttons in the Z space, so forward, backward, off of that canvas. You can do that, although it may or may not make sense. You want to think of the canvas as a 2D plane that you're going to be affecting. There are also plenty of other different objects that you can make with the UI. So say we wanted to make like a title page or something along those lines, we can choose like UI text or something. All of our buttons, if we click on this drop-down caret, are also going to have a text element here. Having a bunch of things just named buttons doesn't really make any sense. So I'm going to actually select this text element, and if I scroll down, I'm going to see this text script component, and I can rename this. So if I type start, you're going to notice that my top button is no longer named button, it's named start. I can do the same thing with this other button. I'll select the text that it's attached to, and then I'm going to type exit on this one. Along with adjusting things like the text itself, we can also do things like adjust the colors of things. So if I select the canvas, I can scroll down, choose Add Component, and type in Image. What will happen then is I'll create an image background for our actual canvas itself. And then all of these also have components that we can adjust and change. So in this case, my canvas has this image on here. And if I scroll down to the image component that I just added, I can change that color to whatever I want. So I'll just go with this weird light blue. And now it has this light blue background. A similar thing can be done with the buttons. So if we select a button, you'll notice under button script component in the inspector, there's a normal color, highlighted color, pressed color, disabled color. We can adjust those as well. So I'm going to turn this to like a deeper blue. For the highlighted color, I'm going to make it green. I'm just kind of arbitrarily choosing colors at the moment. And for the pressed color, I'll make it a dark green. So then if I hit the run button at the top, if I hover over my start button, it changes color. If I click, it'll do something. At the moment, we don't actually have any functionality to our buttons, so clicking on it's just going to change the color. The other thing that you can do with the image thing that we just dropped into our canvas, is you can actually change the image itself and use an image as the background. It's also possible to use an image as a button. The big thing is you're going to have to make sure you import the image as what's called a sprite. So if you remember last time, we used those normal maps, and we had to go into the folder that we import all those normal maps into, and we had to set it to import as a sprite. You basically do the same exact thing, but rather than choosing normal map, you choose sprite. What we can do is I have this start button that's this blue, and I have this exit button that's still the default. I don't necessarily want to go in and actually change like this exit button and all that. That sounds like a lot of work. So on all of our actual components, there's this little gear icon in the upper right corner of them. We can choose Copy Component. Then if we go to the other button that we have, if we click on the same gear icon, we can go Paste Component Values. We will have to change the target graphic here, because target graphic right now, this is actually the top button. We'll have to just click on that real quick and change it to our second button. But you'll notice now this exit button has the exact same values. So it's kind of nice if you need to duplicate just a component itself. The biggest trick though is just make sure that you change the target graphic to whatever your other button is rather than your first one. It's also advised to always keep track of what different elements are. So I know this is my exit button. So I'm actually going to go ahead and just rename this exit, so I don't have to worry about like figuring out what button does what, and it's a little faster for me to find. Again, you can name this whatever you want. I'm also going to rename start, but you can rename these whatever you want, but it's really helpful to keep track of different assets by naming them whatever they're supposed to be. Okay, so now that we have our two buttons in our scene, we can hit run, highlighting, hovering over them. Once this loads. Come on, Unity. I know you can do it. There we go. If we hover over them, they'll change color. If we click, they'll change color, but they don't actually do anything yet. In order to allow these things to do anything, we're going to need to create a script. So what we'll do is we'll go to our assets folder. I'm going to make a new script. You can make these scripts in any folder that you want, but I'm going to go ahead and create a folder first. So scripts. That way I just keep everything nice and organized so I don't have a ton of, if we were just dumping everything in the assets folder, we might have 40 things that we have to sift through right now. That doesn't sound like much fun. Instead, I'm going to make a scripts folder, double click in there, and we'll open up that folder. Then, if we want to make a new script, it's going to be the same way that we've been creating pretty much anything else. We'll right click, choose create, C# script, and then I'm going to go ahead and name this buttons. I'm naming this buttons because I want to make sure that I know what this is, what it's going to be doing. Again, just making sure that you name things properly and making sure you organize things properly is going to be really helpful. What I'm then going to do is I'm going to double click on it, and that's going to open Visual Studio. Visual Studio is a free program that's installed with Unity, and this is what we call an IDE, an Integrated Development Environment. Regardless of what code language you are using, you're probably going to be working in an IDE. For instance, Java has the Eclipse IDE that you can use. There's a couple of other C# IDEs, like there's one that's just Visual Code. Even JavaScript has an IDE, although it's usually something related to web browsers. You may have to log in with a Microsoft account. If it prompts you to do so, just use your CSU EID credentials. Those are linked to a Microsoft account. You can just use those for now. Something else to be very careful of is right here it says public class and then something. In this case, whatever this name is has to be the exact same name as your file that you just created. Like if I were to go in here and change this to hot dog, public class hot dog, it would no longer work. This has to be named buttons because I named that script buttons. So if you need to change the name, you need to change the name in both places. If we look at our current script here, again, you have to make sure that this name right here, public class, is the same as whatever you saved as. So if you didn't rename it, it should be like new behavior script or something along those lines. It needs to be the exact same. So if you change it in one place, you have to change it in the other. For now, we're going to actually just go ahead and delete everything that's in between these curly brackets. So you should only see public class, whatever you've named it, colon, mono behavior, and then 2 curly brackets. What this is saying is we have a public class, which is that toolbox that we talked about earlier. So we have a toolbox here, and in between these 2 curly brackets, we're going to basically be saying these are all the tools we have in here. So these curly brackets are basically everything that belongs to this public class. So what will happen is everything that we type in here has to be in here. So what will happen is you don't actually have to type this out. This is just for demonstration purposes. We'll have a method, which will methods are always going to be denoted. Oh God, it'll automatically fill things in for you. So if it does that, don't freak out. Okay, method. Then you need parentheses to denote a method, and then you're going to have a curly brackets for that. Those curly brackets are saying all of the code that we now type belongs to this method. So all of this is essentially grouped together because of those curly brackets. And then in here, we're going to have a statement. Please do not autocorrect things for me. Thank you. And then statements always need to end with a semicolon. You can think of the semicolon as basically a period. So this here, we have a method here that has these statements that are all contained within these curly brackets. The public class here then has these curly brackets that contain everything in here. For those of you who have done stuff in HTML, you can think of it as like a div tag. So right here, this is your div tag. This is your opening div tag. This is your closing div tag. Anything inside of that is contained within. It's kind of the same structure. The difference is this is just all actions that you're going to use for a tool. Great. So now that we've kind of covered that concept, let's actually write some tools for us to use. So if we think about what we want to do, we have 2 different buttons. We have one that wants to start the game and one that wants to end the game. Okay, how am I going to figure out what I want to use tool-wise? Well, there's the handy thing that I talked about last time called the Unity API. This API reference is going to have everything that we're going to need to actually use Unity scripting. So if we go in here, to our actual code, we're going to think about, okay, we want one class, we want a class, we want a method to start the game, and we want a method to end the game. What I'm doing right now is I'm just making comments to help myself process what's going to happen. If you need to add a comment, you'll just do 2 forward slashes, and then that'll be a single line comment. If you have something that needs to run multiple lines, what you'll do is forward slash shift 8, which will create an asterisk, and that'll be a multi-line comment. And then what we can do is multiple lines here, and then in order to close the comment, we'll just do asterisk forward slash. And those need to be right next to each other. So asterisk forward slash is going to close that comment. Then what we can do is this is going to be a line comment. So if we have something that's really long and we want multiple lines for, you would use this form of comment versus this form. What happens with this single line comment where you have 2 slashes, if I press enter and start to try to type, this is now a comment. It's going to tell us, hey, I don't know what you're trying to do here. This isn't proper code because this is not supposed to be a comment. We would need to do another 2 forward slashes in order to make that a comment. So just know that comments exist and they're really helpful, especially for beginning coders, to kind of organize your thoughts. So I'm going to go ahead and delete this multi-line one because I don't need that. But I'm going to leave this method to start game and method to end game in here just so I kind of know, like, all right, what do I need here? So we'll go ahead and we'll jump over to this scripting API. And I know I need something to load a new scene. So let's type in scene. See what we get. Cool. All right, scene, that's a type of file. Build index. All right, what do we have here? We might scroll through. Oh, what is the scene manager? Let's click on that. We get here then, all right, scene manager, load scene. What does this do? Loads a scene by its name or index in build settings. That sounds like something we can potentially use. Let's scroll down and see how we use this. Okay, scene management.load scene, other scene name. Cool. So what it looks like is what we're going to do is we're going to use scene management.load scene, other scene name. Pretty straightforward, it seems like. So what we'll do is we'll go back to Visual Studio, and we're going to type public void parentheses, and then we want to make sure we have 2 curly brackets. Oh God, what are you doing? Oh, these, no space in between, public void start game parentheses. I got ahead of myself there. So what this is saying is we want to make a new class named start game, and then we need to have curly brackets after it, because we can't just say, hey, hey, here's a method, and then not actually tell it what that method contains. It's going to get mad at us for that. So public void start game, make sure you have these parentheses. That tells Unity, hey, this is supposed to be a method. And then from here, we're going to have 2 different curly brackets that we can put our statements in. So in this area, we'll do statements. Don't actually type this. This is just for demo purpose. And all statements are going to end with a semicolon. Again, it's either a line will either have brackets after it, those curly braces, or it's going to have statements with a semicolon. In this case, you're going to notice that statement is underlined in red. That's basically telling me, hey, statement doesn't exist, you're an idiot, you can't do this. So let's replace this with actual statements that are helpful. So if we go back to our actual scripting API, we know we want to do scene manager dot load scene. So back here, we'll do scene manager dot load scene. Then we'll need to also take note of what else do we need to include with this. So if we go back here, we need parentheses, and then we're going to need to give it the other scene name that we want to load in semicolons. So in this case, if we go back to Visual Studio, we'll go parentheses, quotations, and then we need to copy the name of our scene exactly. So in this case, this is going to be sample scene. We can also rename this, but if you do rename this, it needs to be the exact same name, capitals and everything. It is case sensitive. So whatever your scene name that you want to load into is, make sure you name it that. So in my case, sample scene. And then I'm just going to go ahead and add a semicolon. You will notice, though, we have a problem. It's saying, hey, Scene Manager doesn't exist. How can that be? If we look at the actual scripting API, it says scene manager.loadScene is a thing we can use. You'll notice up here, though, they have this line, using Unity Engine.scene management. That is a package that they are bringing in to the actual script that allows them to do that. So what we need to do is type up here, using Unity Engine.scene management, semicolon. This line up here is saying, okay, import this so that we can actually use the scene manager. Still giving me a red mark. Did I do that right?
Yeah.
Probably. I am really bad at spelling. So, yep. Man, how do I spell words? Manager. There we go. Now it works. Double check spelling. If you're like me and you can't spell worth a damn, you're going to have a fun time. So in this case, then, we've made a method here. This is our method that allows us to load a new scene. So we have one tool within our buttons class. So right now, just a brief overview, kind of putting into context. We created this class buttons. And if you remember the toolbox analogy, we now have a toolbox named buttons. That sounds really funny. I don't know why. And then inside of here, we have a method called start game. So inside of our button toolbox, we have a tool called start game that has the instruction to load a new scene. Great. We also, if we think back, we have one other button that we want to use. So in this case, we're going to type public void exit game. Then we're going to do parentheses, curly braces. And so this is going to be where we define how to use the exit game tool. So, just like last time, you may or may not know where to start. I've done enough of this that I'm like, I know exactly what line to type. But in this case, I'm assuming most of you, this is your first time using C# and Unity. So let's see what we can find about quit. Like, how do we quit an application? So we'll go ahead and hit search. All right, what do we have? Application quitting, application.quit. Let's see what that says. Quits the player application. Okay, that seems like something that actually would help us with what we're trying to do right now. So I'm going to click on that, and now we're going to see what's happening here. It quits the player's application, shuts down the routing application. Cool. Great, this sounds like what we need to do. And then another kind of neat tidbit is the application.quit call will be ignored in the editor. So we won't accidentally exit out of the Unity editor. This will only happen if we have a .exe file that we're running off of. And a .exe file, which we'll get to at some point with this, is basically just a standalone file that allows us to run our game without the need for Unity Engine. For those of you who are gamers, I'm moderately certain that you don't download a project file, download Unity, then load the project file into Unity to play the game. You probably double-click on the icon, and then you start the game. That's the end goal here. So how do we use this? Let's scroll down. So we look through here. Okay, we have a couple of things. They're doing this in update. They're saying if you push a key escape, then application.quit. So it looks like this is the line we need, application.quit. I'm also just preemptively, because of last time, making sure that we need to import the scene management. I'm going to just double check, make sure we don't have to import something new. So using Unity Engine, using systems collections. If we go back to Visual Studio, we have using systems collections and using Unity Engine. Cool. That should be good then. So all we should need to type is application.quit and then parentheses, semicolon. Cool. Looks like that's working. I can hit Control S to save, or we can go to File, Save to save this. But cool. I'm going to come around, double check, make sure everyone's in the same boat. And then from here, I'll show you how to actually implement this into your buttons so that when you click the button, it actually works. Something else that to know is you can name your method whatever you want. I named mine exit game, although Anna just, she named hers end game. Both of those are fine. It's usually best to name something something descriptive. So in this case, exit game. I can probably guess what that's going to do. End game is the same case. I can guess what that's going to do. The biggest danger is when you start just naming things like method 6. I'm not going to know what that does. I would have to look down here like, okay, method 6. Okay, application got quit. Okay, this is going to quit the application. It's a little faster to just be like, see, exit game. Cool, it's going to exit the game. What we'll do then is we need to make sure that we can use this in Unity. So we're not getting any errors. We're not getting any weird warnings. So this should function. So we're going to jump back into Unity. The first thing that we need to do is we need to make sure that our script is actually in our scene. If a script is not attached to a game object, it will not run, it will not work. I had this in the morning class where I tried to do something. I spent about 5 minutes troubleshooting and realized I just never added the script. So what we're going to do is we'll select, and it can be any object in our current scene. I'm going to choose the event system because that's already doing some similar things where it's just calculating out a bunch of events, like button clicks, anything like that. So I'm choosing to put it there just so that everything's nice and organized. You could create a new cube and attach the script to the cube. It actually doesn't matter what you attach it to. I'm just going to do this for simplicity's sake. We have two different ways of attaching a script component. The first one is we can click and drag, and then when we see this blue bar, if we release, it'll show up. The other option is we can click Add Component, and if we search buttons, or whatever your script name is, we'll see buttons. And if I click that, it'll automatically add it for me. So either click and drag from your scripts until you see this blue bar and release, or click Add Component on any object in your hierarchy. Once we have that in our hierarchy, attached to a game object, then we can actually tell our buttons what tool we want them to execute when we click on them. So if we click on the Start button here and scroll down, eventually we're going to find this onClick with two parentheses. So that's an onClick method, and then it'll say list is empty because we haven't told it to do anything yet. What we're going to do now then is click plus, and we'll get this little dialog box that pops up. We'll want it to be set to runtime only. We have two different options here, editor and runtime only. If you set it to be editor, if we accidentally click on a button while we're trying to select it, it might actually execute whatever we're trying to do. So it might be like, oh, I want to move the start button, select it, move it around. All of a sudden, we've loaded it into our next scene. We don't want that to happen, so runtime only. That means it'll only actually work if we click on this play button. The next thing we need to do is we'll see this None Object section underneath that. We'll click on the little circle target on the right side, and this dialog box will pop up. You should be somewhat familiar with this by this time. What we're going to do is select the object that our script is attached to. So you'll need to make sure you're on the Scene tab, not the Asset tab. And I know I attached it to my event system, so I'm going to double-click on Event System to add that. What we'll then do is under No Function, we're going to click, and here we're going to choose Buttons, and we're going to see all of the different things that button is going to actually allow us to do. In this case, since it's my Start button, I want to choose the Start Game method that I defined. There. Cool. So we're going to do the same thing for our exit button. So you'll just select your exit button, you'll click plus. We want it set to runtime only. We'll click the little target. We need to make sure that we're looking through our scene, not through our assets. Choose the object that we attached the button script to or whatever you named it to. And then no function, we want to change to buttons. And in this case, we want exit game. It is possible to have both buttons work as our start game, but that doesn't really make any sense. So we'll choose exit game. The only things that can do anything in your game are things that are in your current scene. So again, if I don't put this buttons script onto my event system, it will not do anything, no matter how much I tell it to do something. The reason being that only things in the active scene are actually going to be called by Unity and actually seen by Unity when you run the game. So now I'm going to go ahead and save. Just Control S or go to File, Save. Unity's going to take its time to think. Cool. We're then going to hit Run. And let's see if our buttons work. Click on Start, and nothing happens. But we do see that there is a red error message down here. So we're going to click Run again to stop that. And I'm going to change over to my console view. If you remember, console is where we're going to see different errors, warnings, and messages that we tell it to present us. So in this case, sample scene couldn't be loaded because it has not been added to the build settings or asset bundle. To add a scene to the build settings, use the menu File, Build Settings. Okay, cool. What are these build settings that we're talking about? Well, let's go File, Build Settings. And you should see something like this. This is the menu that you're going to use to actually build your scene itself. So when you're actually going to build your final product, this is the menu you're going to use. In order to add a scene, we're just going to click Add Open Scene. We should then see something like scenes/menu or whatever your scene is named. Great. We can then go ahead and close this, and we'll want to add our other scene in here. So what we'll do is we'll double click Scenes, and then double click on sample scene or whatever your other scene is named. And then we'll go File, Build Settings again, and click Add Open Scene. So now we have both of these scenes in our build menu. So we should be able to actually use our Start button. So if I close that and go back to Menu, hit Run, and click Start, we load into the other scene. So something else that I probably should have just done instead is you can also go File, Build Settings. Let's say that this wasn't in here. I can actually click and drag a scene in here to add it to the build settings. So just know that that's another way of doing it. We have our first script set up that loads us into our actual game scene. Great. And if we remember from last time, if we open up our sample scene or whatever your scene you made on Tuesday was, if we hit Run, we remember that we're able to walk around and we have these coins that just sort of show up in the environment. Great. So the whole point of making this game was that we wanted to run into the coins and collect them. So we want to grab these coins and increase our score. So in order to do that, we're going to need a couple of other scripts. The first thing we're probably going to do is actually create some type of challenge for the player. So if we had the coins just kind of float there indefinitely, the player could kind of just take their time and wander around. That's not really the point of this game. The idea was to challenge them to collect as many coins as possible. So the first thing we're going to want to do is set up a way for our coins to destroy themselves. I know it sounds very aggressive. Just bear with me. What we're going to do is go to our scripts folder. First thing we're going to do is right-click, create, and C# script. So we're just making a new script, and I'm going to name this coin controller. That will create this new script, and then we can double-click it to open it up in Visual Studio. So we should have now two tabs, our button tab and our coin controller tab. We're going to primarily focus on the coin controller tab, but if we need to, we can go back to buttons to make any adjustments. But now that we're in the coin controller tab, we're going to want to first just start by getting rid of all of this sample code. We're not going to need start or update in this one. The reason being that we're going to be working with time in this case. We don't want to run into the problem of someone has a monitor that refreshes at 30 hertz. So for them, 30 frames is when the coin is destroyed, which gives them an entire second to get it, versus someone with a 144 hertz monitor, they get significantly less time because they will have 144 frames before a second passes. So in just a fraction of a second, their coin will be deleted. So we're going to want to use private void fixed update. And if you remember, fixed update is going to update 50 times every second. So there's going to be 50 physics steps every single second. Cool. So far, all we've been doing is declaring and setting up methods. We've been defining methods. And again, if you think about it, methods are going to be tools. But sometimes, such as with the drill example, we need other items to go along with those tools. In this case, what we can do is we can declare a variable. So in order to declare a variable, we're going to type something like public int time to destroy, and then semicolon. What this is going to be is this is going to be a variable that we can access from our methods. And in this case, since we've defined this as public, we can access it not only from the methods contained within this class, but we can also access it from anywhere else in Unity. So we can have another script access this. We can also have the Unity editor edit this. We're also probably going to want something to keep track of time. So right now we have this integer, which is just a whole number that's time to destroy. So this is going to be the amount of time that needs to pass before we say, hey, destroy this object. We're also going to need something that's a timer. This timer doesn't need to be shared with anything other than the object that we're going to be destroying in this class. So in this case, we're going to do private int timer. And then right away, we can just type equals and then 0. What this is going to do is we're going to create this timer variable, and then we're going to say just start at 0. No matter what we do, we want this to just be 0. And what that'll do is it'll just start our timer right away at 0 when we actually create it. Great. So we have these two different integers. One is marked as public, one is marked as private. If we go to Unity, and we know that we want to attach this to our coin because it's a coin controller, but we want to make sure we attach it to the prefab coin. Because if we attach it to this prefab coin, it'll automatically overwrite all of these. If we attach it to a coin in our sample scene, we're going to have to attach it to every single one. So in order to attach it to the coin prefab, we'll just select it in our project view. And then we're going to scroll down until we see the Add Component button. And then when we click that, we're going to just search for coin controller, or whatever you've named your actual script itself. Then when we press enter, that's going to attach the coin controller script. And I'm going to actually really quickly save this coin controller script here and head back. And when Unity updates, since we have that public variable, you should see time to destroy right here. Now that we've declared both of these variables, we probably want to do something with them. Some of you might have noticed in Unity, we might be getting a warning message right now that says, you've declared these different variables, but you're not using them. We're going to fix that. So in this case, what we're going to do is under fixed update, we want to do, so remember, fixed update is happening every single physics step. So this is happening 50 times every second. So what we want to do is go timer is equal to, all right, timer is equal to timer plus 1. So we're just saying every physics step add 1 to timer. So what will happen is the first physics step happens, timer is currently at 0, so we take 0 plus 1 and then set timer to 1. So we're going, okay, this is 1 then. Okay, then take 1, 1 plus 1 is 2, set this to 2. 3, 4, so on and so forth. And it's just going to slowly increment as we go through. Cool. The next thing that we'll want to do is we want to see if the timer is greater than the time to destroy, because once we hit the time to destroy, we want to delete this object. So what we're going to do is we're going to type if. And then don't type these next few lines. I'm just going to show you how if statements basically work. So if something is true, then do whatever is in the braces. Semicolon. So what this is saying is, if a condition is true, do whatever's down here. So we could say something like, if 1 is equal to 1, do something. Problem we run into there is 1 is always going to be equal to 1. So it's just going to constantly do something. The other option we have is we could say, the other thing that might happen is we might say if 1 is equal to 2, which I really hope 1 is not equal to 2, because then a lot of things break. If this checks and it's not true, it just skips over this. It will never do what's ever in here. So right here, it's just saying check if something's true. Then if it is, do something in here. If it's not, it just skips over. So what's going to happen in this case is we have our timer is incremented. So timer goes to 2. Then we say, all right, is something true? Something is not true. We skip through. It goes back to fixed update. It'll add 1 to the timer again. Check. Out. Back to fixed update. Check. And so on and so forth. So in this case, what do we want to check to see if it's true? Well, we want to see if our timer value is greater than the time to destroy. So what we'll do is timer greater than time to destroy. If that is true, then we're going to do whatever's down here. One quick thing to note is that we are using greater than in this case. The reason we're doing so is if we check to see if it's equal to, we might run into a weird logic error. This would be really rare and really uncommon, where our timer is at, say, 50, but our time to destroy is at 51. Then it skips, and our timer goes up somehow to 52, and it accidentally skips 51. It's never going to destroy itself. It's just going to keep counting up. So especially since we set our time to destroy, since we're actually going to set that, we could accidentally set time to destroy as -1. And if we accidentally set that as -1, 0 is never going to be less than or is always going to be greater than -1. So that's always going to delete. But the big issue we run into is if we set it to equal to 0, if it's counting up, is never going to be equal to -1. The other thing to note, you're not going to actually type this, is to do equals and to check if something's equal to, you're going to type 2 equal signs rather than 1. 1 equal sign means set timer. It means set timer to 0. 2 equal signs means is timer the same as time to destroy. So in this case, we'll just keep it as greater than. Then what do we want to do if it is greater than? Well, we want to destroy our coin. How are we going to use destroy? This is basically just checking if something's greater than, but we might not be familiar with Unity's destroy. So let's see what the API has as far as destroy. Well, we have a couple of things. We're not using network. We're not using subsystems or any of these other things. So our best bet is probably object.destroy. What does object.destroy do? Well, it removes a game object, component, or asset. The object, obj, is destroyed immediately after the current update loop, or t seconds from now if a time is specified. Cool. That sounds kind of like what we want to do. Once our update loop figures out, once that update loop runs a check and figures out that, hey, our timer is greater than the time to destroy, we want to destroy something. So we'll go down here and figure out how to use it. Okay, destroy game object. Seems simple enough. We're also going to check to see if we need to import any packages. Doesn't look like we do. So we'll go back to our demo assets. So if timer is greater than time to destroy, we'll go destroy and game object. And you want to make sure that it's the lowercase game object, not the uppercase one. And then from here, we just need a semicolon. And so what this says is destroy the game object that this script is attached to. So the game object is the component the game object this component is attached to. So it's going to destroy the game. It's going to destroy the game object that this script is attached to. Since we've attached to our coin, it's going to destroy the coin. So a quick recap here. Public integer time to destroy. So we've created two integers. One is a public one that we can access in the Unity editor. The other one's private that only exists within this class itself. Then we have this fixed update, which is just going to run 50 times every second. And then we say timer is equal to timer plus 1. So we're just adding 1 to our timer every time we run that fixed update. And then we're checking to see if the timer value is greater than the time to destroy. Since that's adding every single physics step, we would have 50 checks per second. So if we wanted 1 second, we would set time to destroy at 50. And then once the timer hits 50, that'll be 1 second, we destroy it. Then from that point, we just destroy whatever this is attached to. So I'm going to hit Control S to save this and quickly jump into Unity. I'm then going to set my time to destroy to be, let's go with 150 for the time being. So that'll be 150 physics steps or 3 seconds. If I click Run, I can see that I have a couple of coins here. They're just kind of floating, hanging out, and now they're gone. They just deleted themselves. If I go back here and type time to destroy 5,000 and click Run, you'll notice that the coins are here, and they're going to stay around a lot longer this time. So at this point, the coins were destroyed when I was at 300. Now they're at 5,000, so they're going to take much longer to destroy themselves. Where's my mouse? There it is. So we can adjust this value as needed. If we go back to Unity, so I was going down to my project panel here and assigning the time to destroy in my area here. So let's go back to that 300 here, time to destroy 300. I can overwrite that value for any of the coins in my scene. So you remember we were taking prefabs and creating them, but I can go here and select coin 5. So select coin 5 here. I'm going to just raise this up. And I'm going to set this one to be 5,000. So now if I hit Run, most of my coins are going to be deleted after 3 seconds. So those deleted, but I still have one here. This is the one that I just set to be 5,000. So every single coin in your game can be adjusted on its own value. So if you wanted to create variable destruction, you can. So we have one more that we want to build, and this one's going to be based around using our player to basically bump into, once it bumps into a coin, we want it to actually collect the coin and increase the score that we have. So what we'll do is we're going to start out, we'll go back to Unity. I'm going to go back to my scripts folder. Plot twist, I'm going to make a new script. So yeah, sorry for the spoilers. So create C# script. And I'm going to name this coin collector. Again, you can name this whatever you want. You could name this cheeseburger. You could name this game controller. It doesn't really matter. I'm just going to choose to name it coin collector because that's going to tell me what this is doing. This handles the logic to collect the coins in our scene. Cool. So we have our coin collector. I'm going to double click that to open it up in Visual Studio. Then here, I'm going to go ahead and just delete everything again. Oops, except for those. I need that curly brace. Oh God. I need this curly brace, so bear with me for a moment while I figure out how to use a keyboard. Sorry, it's back to elementary school. So once we have this set up where we have our curly braces and our class, we're going to need to add a little bit of logic here. So the first thing that we need is we know we need a value to hold our current score, the amount of coins we have. So let's go ahead and just declare that public integer score. So public int score, I can't spell, semicolon. So same thing that we did on our coin controller, we just said public integer something. In this case, public integer score. The reason that we want score to be public is so that we can access it from anywhere. We might have a scenario where we want to actually set the score to be something, we might want a scenario where we want another object to interact with our score. Maybe we have, like, if your player dies or something, you lose 10. So we want to leave this public so we can interact with it in other ways. We're not going to do anything that strictly requires it, but it's something nice to have. The next one we're going to do is we need to make sure that our score starts at 0 every time. So we're going to go public, void, start, then parentheses, and curly brackets. Oh God, what did I just type? It's been a long day. So press enter, and we have public void start. If we remember from our earlier example, start does things at the very beginning of the game. So whenever we load up this level, we're going to say score is equal to 0. So what we're doing here is just saying as soon as you start the game, set the score to 0. We don't want it in a situation where someone else plays, they get up to score 200, and then we jump in and it's like, oh, why is my score 200? Like, I didn't do anything. We want it to start at 0 all the time. So what this script will do so far is it'll say, all right, create a score value. Right now, it just isn't set to anything. We could, in theory, say set to 0 here, but since we're going to be setting it in the start, we don't need to. Then what the script is going to do is going to say, okay, when we start the game, set the score to 0. So when we load into our level, set the score to 0. Great. Everyone good so far? Ouch. Cool. After we set the score to 0, we're going to need to figure out, all right, what we want is, from a logic standpoint, is we want the player touches a coin, then when they touch the coin, we add 1 to the score. Then after we add 1 to the score, we're going to want to destroy the coin. What's great is we already know the destroy command, so we're not going to look that. We don't need to look that up. We also already know how to increment things. If we look at our coin controller, we know that we can say timer is equal to timer plus 1. So in this case, we could just say score is equal to score plus 1. Cool. We know 2 of the bits and pieces that we need. The problem is we don't know what to do with this touch as a coin. I'm going to give you a little hint. It has to do with what's called a collider. So if we go into our coin, I'm actually going to open the prefab. We're going to go into our coin and we're going to say, okay, we have this thing called a collider. What does a collider do? Well, let's go into Unity and let's type in collider. Cool. So we have colliders attached, all right. Oh, what's this on collision enter? Maybe that's what we need, or maybe it's on trigger enter. Let's see what these two things are. Because when we enter something is when we first touch it. So on collision enter is called when the collider or rigid body has begun touching another rigid body or collider. Okay, cool. That's something. When a game object collides with another game object, it calls on trigger enter. Okay, so these seem kind of similar. So let's open up both of them. Let's look in here. Okay, let's see. So on collision enter, for each contact point, all right, this already seems too complicated for us to go into right now. Let's try checking this out. So when it collides with another game object, it calls the on-trigger enter. Fixed update function when 2 objects collide. Colliders involved are not always on the point of initial contact. Okay, cool. Let's see, how are they using this? They're setting up some stuff in start. They have their update here. So on trigger exit, on trigger enter. Okay, cool. This looks more like what we want to do. On trigger enter collider other. We want to set a speed and then we want to actually change a color. This seems a little bit more in line with what we're wanting to do. We want to increment a variable and then we want to destroy something. So let's try using this on trigger enter. Let's first really quick make sure we don't need to import anything using Unity Engine. we should already have that. We should be good. So let's go back to Visual Studio, and let's go private void on trigger enter. Cool. So what this is saying is when we enter in, when we touch another object that has a collider, we want to grab that collider, and we're just going to name it other in this case. And so now what we can do is we can check things about that collider. We can say, like, all right, what is that collider? We can figure out things about what we're touching. So in this case then, we're going to say if, and then we're going to need something that says the collider we touch is a coin. Then we're going to want to add to, oh God, this is why you use comments. Add to our score and destroy the coin we are touching. So this is a great way to use comments to kind of organize your thoughts. So right now, if the collider we're touching is a coin, then we want to add to our score and destroy the coin we're touching. So let's start by we already know how to add something to our score. Let's just start by doing that. We're going to go score is equal to score plus 1. Cool. So we're just going to add to our score whenever we touch it. The next thing we know we need is destroy. So why don't we try typing destroy, and then we're just going to type game object. Well, oh God, I really need to figure out how to type. Destroy. Well, one of the issues we're going to run into here is if we hover over this, the game object is the component this is attached to. So we run into two problems here. The first thing is if we attach this to our coin, then what happens is when a coin touches a coin is maybe what we're thinking of doing, it's going to destroy itself. We have two issues here. The first thing is we're destroying the coin, meaning we also destroy our score integer, meaning that our score is going to just destroy itself there. The other problem we run into is our coin, all of our coins are going to have a separate score. So we're probably going to actually have to attach this to something like our player. The issue we run into if we're attaching it to our player is the game object this component is attached to will be destroyed by using game object. We don't want to destroy the player because then our game doesn't work anymore because we can't interact. So what we're actually going to do is type other.gameObject. What this is saying is whatever that collider we just bumped in with, grab the game object that's attached to and destroy that instead. So when we say collider here, what that's saying is whatever we've just bumped into, we're going to grab the collider that's attached to that object we bumped into. Then what we can do is say, all right, whatever that collider is, grab the game object that's attached to and destroy it. So that's what this code is saying right here. Cool. So we're adding one and we're destroying. The next thing we need to do is figure out how to determine whether what we bumped into is a coin. There's a couple of ways to do this, but the easiest way is to use what are called tags. We could also compare the name. That's going to require getting the name from the component. That's going to get a little complicated for our purposes right now. Just know that there are multiple ways to do anything in code. I could grab the name of something. I could figure out if it has a collider that has the exact properties that we're doing. Or I can use a tag in this case. So we're going to go other.tag. And then remember, if we want to check if it's equal to, we need to use two equal signs. And that's going to be essentially same as, and then in parentheses, we want the name of the tag we want to search for, in this case, coin. So what this is saying is if the collider that we just bumped into has a tag, and the tag is the same thing as coin, then we're going to run this script. So one of the things that Kyle just brought up that's a really good thing to know is right here, we have this code that says on trigger enter, and then we're looking for a collider. Then whenever we find that collider, we're going to name it other in the purposes of our script so that we can access it. We could name this collider. We could name this pizza. It doesn't actually matter what we name it, but say we did name it collider, then what we're going to have to do, though, is we're going to see the name other does not exist in the current context. That's because we just renamed the collider that we're accessing. So we need to do collider.tag in this case, or collider.gameObject. So just know that this is actually basically grabbing a variable for us that we can then interact with and use. So just know that whatever this is being named when we're doing this on trigger enter is going to be down here. It defaults to other, but in this case, I've changed it to collider. In all of your cases, you should probably just leave it as other. It won't make a huge difference, but just know that that is the case.
If you're coding something much bigger, would you want to change it more specifically so you can keep track?
Potentially, you might want to change it if it's, say you were doing like multiple trigger events and you wanted to just kind of denote like which trigger event faster. You could say private void on trigger enter collider coin collider. Yeah. You might name it that, and then you'd say like, all right, bullet collider, player collider. In which case, then you would just in that actual block of text adjust it there. Something else that is very important to know about is if I were to say I was to try to go public void, you don't need to copy this down, update, that's a method, and say I was to try to do like, okay, I want to access the collider again, go collider dot game object. Oh, that's not working, right? Collider, I want it to be lowercase, please. Let's just click off, see if that works. Collider dot game object dot set active. Don't worry about what that exactly means. We're going to get an error that says the collider attached to this game object, but it's going to give us an error because the collider is actually only exists in this block of text. Right now, we're not accessing the collider that we're referring to in this block of text, which is the other objects collider. We're referring to the collider attached to the game object this script is attached to. So just know that we can't do that. The other thing too is say in here we were to like make an integer, like say we were to do integer int times we bumped into something. If I were to go down here and try to say times we bump, it's going to be like, what are you doing? This doesn't exist. The problem that we're running into is there is a scope for every variable you make. Whenever, so the reason that we made an integer up here is so that anything we do in any method can access that integer. If we make an integer within a method, so like say we were making something like, again, going back to that toolbox example, say we were doing something like a drill. We might need something that represents a drill bit, but how many other tools do we have that actually need a drill bit? So we might want to do, in here, game object drill bit, because the only place that we're going to need that drill bit is within this tool right here. It doesn't make sense for, say this is like a hammer. It doesn't make sense for a hammer to need a drill bit. So just know about that. If it's ever giving you weird things like it doesn't exist in the current context, that error message usually means this does not exist within this block of code that you're trying to work with. And a block of code is basically from this curly brace to this curly brace, or from this curly brace to this curly brace. So it's just a series of statements in between curly braces. Cool. So sorry about that tangent. It's just something interesting to note that just came up. But what we're going to do now is we want to make sure that this is actually working within Unity. So the first thing we want to do is actually attach the script to something. In this case, it makes the most sense to attach it to our FPS controller. So we're going to select our FPS controller in our hierarchy, scroll down, and we want to attach the coin collector script. So we can do that by either searching coin collector, or by clicking and dragging that script onto our FPS controller. In my case, I'm just going to add it by clicking add component. Cool. So we have our coin collector. That's all set up. Let's try hitting run once that's done. Cool, so we run around, I run into this, and I have no idea whether my score is going up. It also doesn't seem like it's actually deleting this properly. I wonder what's happening here. So a couple of things. The first thing we're going to want to check is by going to our coin prefab, we're going to scroll down to that, or scroll to wherever the collider is, and we need to make sure that this is triggers checked because we're using on trigger enter. So whenever our player enters a trigger, it's going to do something. We just need to make sure that this mesh collider is marked as a trigger. So we'll mark that as a trigger, and we should be good to go. So now let's try hitting run again. And my coins just fell through the ground. Okay. For now, if you're using rigid body, just ignore graphics or ignore gravity. I don't know why that's actually causing this problem. I'm just going to ignore that for now. In this case, then, I have our coins, and if I run over to one of these, I touch it, still not working. I wonder what's happening. So this is something that comes up a lot in coding. You have something that should, in theory, be working, but it's not. So one of the big things you want to do is just think about troubleshooting. Okay, well, we know that when it touches a collider that we should be doing something. What should we be doing? Well, we want to check if the collider is actually a... the first thing that we wanted to do is check to see if the collider is a tagged as coin. Well, let's go to my prefabs. Oh, God. Let's go to prefabs. Let me select the coin. Let me see about that tags. Oh, tag untagged. Our coin does not have a tag right now. So I'm going to select that, and I'm going to go to add tag. Here, this will open up the tags and layers thing. We're going to see tags list is empty. I'm just going to click that and type in coin. Then click save. That is added in a tag for us. Great. So now if I hit run, let's see what happens. If I go over here, I see my coins. If I touch it now, still not anything happening. Wonder why that is. So in order to use a on-trigger enter, we need to make sure that our object actually has a collider. If we scroll through here, we'll notice there is nothing called a collider on here. So let's go add component, collider, and I'm going to just select capsule collider from that list, and this is on our FPS controller. So let's add that, and now let's see what happens. So we'll hit run again. If I touch it, still not happening. I wonder what's going on here. So again, this is a process that you're probably going to have to go through where you're just double checking, seeing if something is working. If it's not working, we need to figure out like, okay, what's going wrong, those types of things. So in this case here, we have our capsule collider. That seems like that should be working. If we go to coin, we need to make sure, oh, I forgot to tag our coin. So I'm going to make sure I select coin. Let's try this again. Touch it. Oh, it deleted. Touch this one. It's gone. So this is something that is really helpful to know about, is just this process of troubleshooting. I'm going to come around. I know I just went through a lot of steps really quickly. I'm going to come around and help you out with that, but I just wanted to demonstrate this idea of troubleshooting. Just going through step by step and figuring out like, all right, I tried something that should be working. It doesn't look like it is. Let's see if there's any changes that I know I can make. Oftentimes, too, what you'll have to do is you're going to actually have to go seek out potential fixes. So you can do that either through the IDE that we've been going through or by going to places like Unity forums and seeing if there's anything here. Google searching your problem is also great. Like if I knew there was something where it's like collider is not working Unity. Usually you want to be more specific. So let's go collider is not triggering a destroy. On trigger exit not called on destroy. Okay, cool. Maybe this is something you're going to want to read through here. They have code samples, those types of things. Another great place, if you don't want to use the Unity forum, or if you're doing something non-Unity related, is Stack Overflow. I absolutely love this website. It's a forum for anything code related. So there's a bunch of Q&A where you can browse questions, be like, I have these types of things that aren't working, something for C#. So this will have things that are related to Unity, as well as things related to JavaScript, things related to Python, all of these great things. So definitely check out those places if you're having issues, and for some reason I am not immediately available. When in Visual Studio, when we have this tag as coin, this has to exactly match the tag. So if I had undercase coin, the tag that I create in Unity has to be lowercase coin. If it's uppercase, it has to be uppercase coin. So just know that those have to match. If we go back to Visual Studio, we don't actually have if you try running this, we have no way to know what our score is. So something that's helpful for us is if we go under our score, so just underneath the line that says score equals score plus 1, let's type debug.log, and then in parentheses, score. What this is telling Unity is, hey, every time we increment the score, tell us what the score is. And this is going to show up in the console. Now, the one issue we're going to run into is this is only a very temporary thing. This is going to be used for us to make sure that the actual score is incrementing properly. So debug.log score. If I go back to Unity then and hit run, when I bump into a coin, you're going to notice in the bottom left corner, it says 2 now because I've touched 2 coins. When I hit this one, it's going to go to, oh, it just deleted it. It would have gone to 3 if I actually hit it. But what we'll do then is I'll exit out of this. And if I go to console, we'll see, all right, Unity engine.debug log object, it's telling me 1 and then 2. So it's telling me those values. So what that line of code we just added in, the debug.log, is it's printing those values onto the console. This is really great for debugging purposes. So like, say say I was doing this and I didn't have any infrastructure yet to display the score. I'm just going to hang out and just let it tell me the score to make sure it's incrementing properly. The problem we have now is the player won't have access to the console when they're playing it. We're the only ones that are going to have access to this console. So what we're going to have to do is build some way for the player to actually see this. In order to do that, we're going to use our good friend Canvas. Not the program that we use for assignments, but the feature in Unity. So if we go to the Create menu, we can go UI and then Canvas. This is going to be the same thing that we built for our menu system. The difference is, though, in that canvas, we're just going to right-click, choose UI, and we only want a text object. Make sure you're using text and Text Mesh Pro instead of Text Mesh Pro. And so here we're going to get a bunch of things related to text. Now, since we're going to be using an overlay, it doesn't actually matter where this, where our actual canvas is. Like, this can be floating anywhere in our scene, but since we have it set to overlay, it'll always just overlay on the camera. You can then edit the text by selecting it, and then same way that we did with the buttons, just changing it. So I'm going to just change this real quick to score, colon, and space. Then I'm going to change the color to just be, I'm going to change the color to be white, just so that it is more visible when we're playing. Then I'm just going to move this around the canvas so it's kind of the upper left corner of the canvas rectangle. That's just so it's not in the very center of the player's view when we play. So once you have that set up, if you hit run, you're going to see score in the upper left corner. The problem we have, though, is if I touch the coin, it's still getting deleted, but that score isn't doing anything for us. So I touch the coin, it's deleted, but score isn't doing anything. So what we're going to have to do is we're going to actually have to use a script to tell the score to update its text. So one of the things that we can do is we can access, we can actually change the text based on whatever we see down here. So what we're going to want to do is up here underscore public, public int score, we're going to write public capital T text, and I'll just name this text. So right away we're going to run into a problem. The type or namespace of text cannot be found. Are you missing a using directive or assembly reference? What that means is we don't actually have that package importing. So what we're going to need to do is up here under using Unity Engine, we're going to type using Unity Engine dot UI, semicolon. And what that's saying is, hey, Unity, we want you to actually use this UI toolset because we need to use it in this script. Typically what you want to do is use as few of these as possible just to reduce the amount of load time, the amount of things that Unity has to keep track of. So in this case, though, we do need this in order to use text, and as soon as we enter that in, you're going to notice that this line no longer has red squiggles under it saying, hey, this is wrong. Cool. So what we want to do then is if we go down here, rather than saying debug.log score, I'm going to go ahead and just delete that. I'm going to type text is equal to, or is set to, and then in parentheses, score, colon, space. Then, oh god, typing things randomly. We're going to go plus score. So we're saying here, oh, why are you mad at me? Sorry, we have to go text.text. You're going to run into these weird things that happen sometimes where you have to say this text object and it's text. So we have to go text.text equal to score, semicolon, plus score. What we're basically saying here is grab that text object that we just gave you and set the text component of it equal to score and then print whatever our score is actually equal to at the time. So what will happen is when we hit our first coin, it'll set the, when we hit our first coin, it's going to add 1 to our score, setting it to 1. Then it's going to say, all right, update that text to score plus 1, so it'll say score 1. Then destroy that coin. And it'll just do that every single time we run into a coin. So I'm going to go ahead and save this. And then when we go into Unity, on our FPS controller, we should now see two things here. Our score value that we can adjust, which we'll want to just keep at 0 because it's best to not adjust that. And then our text. For text, we're going to want to click on this little flywheel over here. And then it's automatically going to open up the same dialog box we've been using to set objects. And there should be only one option for you, unless you have multiple text sources in your scene. And you're just going to double click that to set it. What will happen then is if we hit run, and we run over here to collect this coin, we're going to see it jumps up to 1, then 2. And if we run over here, 3. I missed them. So you can see now my score in the upper left corner says 3. So that's all that line was doing, was it just said, hey, that text object that we made, change what it says. So the next thing that we can do is, we don't really want our player to have Unity in order to play our game. Plus then, if they don't know what they're doing, they might accidentally bump into something and adjust a value and then it breaks the game. So what we're going to do is we'll just make sure we save our scene, so File Save or Control S. And from this point then, we'll go File, Build Settings. In our build settings, we've already set it up to have both of our scenes in it. And then what we're just going to do is click Build. And then we're going to just find a folder to save this in. So I'm going to go New Folder on just my drive. Don't save this in your project folder, like go either to the desktop or to another folder. And I'm going to name this art357exe. I'll double click on that file and then click select folder. And now Unity is going to take a moment to actually build this project for me. So this will always take a moment. It'll have to bake some lighting, and then it's going to actually do all the shader compilations. So this will take a moment, but it's just going to basically build the scene. Once it has finished building, let me navigate to the morning one so I can show you what you should expect. So once it's finished building, you're going to have a folder that looks something like this. It'll be named whatever you just named that folder, and it should have a crash handler, a demo.exe, and then a couple of other files here. If you double click on the demo.exe, whenever it actually loads up, it should start your game. And this is a file that you can actually put on any Windows computer. If we were doing something for Mac, we'd have to make sure that our build configuration was set to Mac. But in this case, we're going to have, all right, here's our configuration. We want it to be display 2, which is this one. For me right now, I'll just hit play. It's going to pop up with Made with Unity. And now I can click Start. And it'll load into my game. I can run around, pick up some coins. My score goes up. Awesome. So now I can play this on any computer I want. I can bring this home with me. I can load it on my friend's computer, and I can share this file. This is also the file that you will be turning in. So I'm going to go ahead. I didn't add in anything to actually exit the game, so I have to quit it kind of a sketchy way. But just note that it's usually common practice to have like a key press to exit back into the menu or a key press to actually quit the application. So just know you should probably add that in. We didn't get that far today. But the biggest thing here is just knowing that you'll need to actually build it as a .exe file. And this is going to be pretty much regardless of whatever game engine you decide to use. If you're using Unreal, if you're using GameMaker, you need to make sure you have a .exe file. So when it's done building, it'll just pop up with this. If you're doing something JavaScript-wise, in that case, then you'll just be having the actual website linked that you'll send to us, or you'll send us the entire file with everything neatly contained and organized. But cool. If anyone has any questions, feel free to reach out to me. With that, though, that is everything that we'll be covering here. One of the big things I do recommend checking out is the Unity roll ball tutorial, so Unity Rollerball. This is a really good beginner tutorial. It'll cover a lot of the things that I just discussed, as well as some other stuff. So you'll start here. It'll just walk you through building this really simple game.